Hello. Welcome to Microsoft Community Insights podcast, where we share insights from community experts to stay up to date in Microsoft. I'm Nicholas. I'll be host today. In this episode, we will dive into functional programming. But before we get started, I want to remind you to follow us on social media so you never miss an episode and help us to reach more amazing people like yourself. Today, we have a special guest called Simon Painter. Could you please introduce yourself?
My name's Simon Painter. I'm from the UK, as you can probably tell from my accent, roughly from the middle of the country. I'm from the West Midlands, and I've been a .NET developer for something like 20 years now. I started working in .NET 2, and I've worked in pretty much every version of .NET that's ever been. And these days, of course, I'm big into functional programming, amongst other things. And that's what I'm here to talk about today.
Yeah, so before we dive into the theme of friendship programming, can you just tell us a bit about yourself, like what you do in your day job?
Sure. So I work for a company called Talos 360. They're a .NET software as a service house. They're based vaguely near the Manchester area. Although I work remotely, which is great for me because I have children. So it
Yeah.
means I can be there to drop them at school and all that in the morning. It suits me very well. And they make software for use by recruiters. So it's stuff like candidate tracking, like upload a CV, track them through the process, make comments, evaluate, do give evaluation quizzes out to your candidate, and then aggregate together a list of the short list of the best candidate, all that sort of a thing,
Okay.
or arrange interviews, all the sorts of things you do when you're trying to hire new staff. So that's what we do. And thankfully, and rather conveniently for me, they're actually a functional programming house. That is the style that they write all of their code to,
Okay.
which is handy for me. So it meant that rather than have a lengthy period of learning what functional programming is as I came on board, I didn't need to do any of that because I sort of literally wrote a book on the subject once, and it meant that I could just get straight on with a little bit. There was some in-house style to learn, but get more straight on with the coding when I started. So I think that was a relief to them in some ways. Although they have had to put up with all of my terrible jokes in meetings. That's just the way I roll.
Okay. So I'm curious about what's functional programming because I've not heard about it in my time. I
Sure.
know about
Okay.
object-oriented, different type of programming, but I've
Mhm.
not heard about functional programming. What it is?
Right. No problem. Okay. So functional programming is a style of programming. It's not like an add-on or something that you install or use that way. It's just a way of programming. But it's very different to OOP, that is object-oriented programming, of course. Um, Uh, it, basically, the name is poorly chosen for a start.
Yeah.
I mean, functional programming. Then does that mean all the rest doesn't work? It's a terrible name. It's a bit like
Yeah.
organic food, or what's all the rest of the food? Is it inorganic rocks and stuff? No. It's called functional programming because everything's made of functions. Everything in functional programming is made of functions, and it's functions which are sort of plugged together like Lego bricks. If you imagine a Lego brick as being a small little function, you could place many Lego bricks together to make a larger, more complex function, and then to a larger, more complex system. But the whole thing is composed of many little functions glued together. Um, this is actually something that's been in .NET in principle since about C# 3. Link is based on functional programming. If you think about link, when you call a select, what you were doing is those arrow expressions, those arrow functions you write.
Yeah.
Those are functions. Those are little tiny functions which are being passed into another function as a parameter and then executed by that function in a certain context, which is it takes it and then runs it against every element in an enumerable. That's a basic functional programming concept. Functions passed around as if they were variables, and functions called by other functions. And by
Yeah.
doing that, by passing a function into a select statement, you are composing two functions together to make a larger, more complicated behavior.
So I'm not in a developer and like industry, but w- is it good to have a lot of function in a program? Everything in function, like too many functions.
I never thought about it that way. I suppose so. It's got a few benefits.
Yeah.
I mean, one is reuse. If you are being sort of enforced by the programming style to write everything as small, little, tiny, composable functions, and you're tending to make it easier to reuse stuff. I mean, that's one thing.
Yeah.
There are
Reusability.
absolutely that is definitely a concept. There's no state as such in functional programming. So OOP is predicated on the idea that you have this big blobby state object, for example, and then your program runs and updates state. It updates this object, it pulls data from it, pushes data to it. We don't have a state object in functional. We kind of have this state as a concept, but it's more like state is a transitory continuity of objects, which one sec, excuse me, sorry, which exist only for a moment. And what you do to update state is instead of literally updating the object, you take the old state object, some parameters, some little bits of data, and an instruction, and create a new state object based on the old one. Which sounds it may sound on the face of it a little overly complicated, but it gives you this advantage of incredibly predictable state management systems. You get code that is, and that's the really big one. You're writing a code base which is really, really predictable. Everything is written with a principle in mind. We can call it pure functions or something like that. The idea is that every function that you write is written in such a way that it will always return the same data given the same parameter values in. That is the same parameter values. So if you're writing an add function, you give it a 10 and a 20, you're always getting it back a 30 every single time, and nothing
Okay.
else. It involves eliminating the concept of side effects. Side effects are things like throwing unhandled exceptions or skipping to other bits of the code base any other way, or updating something that isn't contained within the function itself. Once you get rid of all those side effects, all of your code becomes really very predictable, which makes it easy to do things like writing unit tests, or it means that you don't have to worry about things like side effects happening when you're running, say, a whole load of processes in parallel. You tend not to get things like resource contention happening in cases like. Uh, so sorry, I'm just recovering from a cold.
No worries.
In cases like where you're doing multi-processing on data with lots of different tasks running all in parallel, it tends to handle those sorts of scenarios really, really well. So
Yeah.
as your function, stuff like that tends to be supported by functional programming.
So I'm just curious to know, since it's like functional programming C sharp, can you do that with different programming language like Python as well?
Yeah, yeah, you can do it with just about any programming language around, as far as I'm aware. I mean, I haven't tried it with every single one. Functional programming is actually
Okay.
really, really old. It predates .NET actually by decades. The very first work that was done in what became functional programming eventually was done in the late 1800s. To some extent, it predates the modern concept of the computer. Um, the first functional programming language was made in the late 50s. It was called Lisp, written by a guy called John McCarthy. So functional programming has been around absolutely ages. And for almost any given programming language, I guarantee you that you write programming language in functional programming, you'll probably find there's already a book on the
Yeah.
subject, or several. Python, for example, I'm almost certain that book exists. I think I've seen it around. C++, JavaScript, certainly. JavaScript supports functional programming very, very well, better than most programming languages do. Just by the sort of fluid nature of JavaScript, it can be everything and everything to everyone, except when it isn't, because it's JavaScript and occasionally it's an empty array or something. But JavaScript does functional very, very, very well indeed.
Yeah,
And Java,
because
of course. Java and C# are remarkably similar to each other.
yeah, I take it C sharp is one of your favorite language, right? Because you wanted than other like language, like for example, could be I won't mention Bash because Bash is not a programming language. It could be like JavaScript and Python and stuff.
JavaScript has a special place in my heart, just because, in part, because it is just so wild and woolly and weird, and I
Yeah.
quite like JavaScript. It's the wild west of programming. Everything is possible except when it isn't. Um, but yeah, I mean, C# is the language that I have spent the entirety of my professional career working in. When I got my very first job in the early 2000s, I was actually trained as a Java developer. That was what I did when I did my degree at university. Actually, the language I learned at university were Java and C++ and C of all things. I mean,
Okay.
C is still very useful and very important, but
Yeah.
most of us don't work in it. And those were the languages I studied at university. But as soon as I got my first professional job, they wanted me to work in C#, and I'd never seen it before.
Yeah.
But I had done Java, and of course they are very transferable.
Yeah,
C#
because
and Java skills.
yeah, I think the fundamental will be the similar,
Yeah,
like
yeah. There's some
declaration,
terminology
classes,
different, bit of
functions. Yeah,
yeah. There's a little bit of syntax different, bit of
yeah,
terminology different, but it's a totally transferable skill. So from that point on, in about when would it be? About 2005, 2006, something like that. Since that day, pretty much I've just been a .NET developer, and that's what I've worked in ever since. As started, as well as a bit of JavaScript on the front end. I do know Python as well, as it happens. I run a code club in my kids' school, and I teach them Python. Python because we use the code club material. That's codeclub.org, and that's largely Python driven. And Python's both open source and a scripting language, so it's handy for teaching to kids.
so let's talk about that code club. So did you say you teach kids Python at your local
Hmm.
school? Where about is
I
that? Is
do.
that where you're based, or is it open to any other like attendee that want to join the club? Or you have to be a
That is
student?
Yeah, that is literally my kid's primary school. Primary
Ah,
education,
okay.
for reference, that's the school you attend in the UK between the ages of roughly 5 and 11
Yeah.
ish, depending on when your
Ah,
birthday
okay.
is. So it's for smaller children, and yeah, you can't. It's not one of those schools that's just open to anyone. There's rules here about who's allowed to attend which school, usually based on where you live. So it's
Yeah.
actually the school that my children attend, and both of my kids are members of the club as well. So it's run well. It's on break at the moment because there's some exams are being worked on, and we're coming to the
Yeah.
end of the school year. But it generally runs on a Monday, and it runs for about an hour or so after school. And I teach them a bit of Python. And to try and give them a bit of context about how does the wider world of computing work, and I try and teach them what it is like in the computing industry, and what's the truth about the sort of rubbish that films teach you about how computers work when that's not quite how the real world is, especially hacker films. I have a love-hate
Yeah.
relationship with hacker films and how accurately and not they portray our world. And I did ask my brother, who is a school teacher, what would be a lovely way to motivate the kids and to, like, I thought
Yeah.
being a
I
school
would.
teacher himself, he would know all of this
Yeah.
sort of stuff, and it turned out to be stickers. Just give them
Yeah.
stickers,
Well, yeah.
and
It
I
could be
thought that
like
was
making a
ridiculous.
game. Could be like making a Pac-Man game in Python, something like to
Yeah,
motivate them, like win against each other for stickers or something challenging,
yeah,
something like that.
it is that sort of a thing. There's actually a load of content already made on the Code Club website. So yeah, they do make
Yeah.
little games. They do make like little animations. There's one of the early ones where you have to make a rocket to make it fly up into space, and you have some readouts that tell you how much fuel it's burned and whether your rocket's made it to space and
Okay.
stuff. That's cool little stuff. And to be honest, one of the most rewarding moments for me is often when one of the kids just starts and they write their first "Hello World." And would you believe? Like, I mean, I've been working in some form, either as a student or as a professional in programming,
Yeah.
since 1996, and I have long forgotten the joy of the "Hello World." And so it is so rewarding just to see kids excited because they made their
Yeah.
computer write something. And that's
Yeah.
lovely.
Because that's normally my first program I had a world thing to do,
Yeah.
even for any industry like Microsoft had a world. So I think you wanted to show us some like demo about functional programming and how it works.
I can show you a quick little demo.
Yeah.
Let's hope this
So
works.
we can see.
I let's see. I'll just present. No, present. Share screen. Share screen. Mm, Let's see if this works. Fingers crossed, everybody. Is
There we
that
go.
working? Okay,
Yep. You
I'll
may
see if
have to
see how
zoom in a
quick.
bit.
Yeah, sure. Let's blast this up. How's that?
Yeah. Brilliant.
Oh, okay. Now, hopefully this is going to work, but I have terrible luck when it comes to live demos, so we'll give this a go. Right, I've made a super stupid, simple little example of, I want to get an order history, and this is totally imaginary, and I've just made some static functions, which basically are my virtual SQL server, and they could be anything. Could be a web API, whatever, it doesn't matter. But the point is, this represents something where we're going to go away out of the code base and something external where it's possible that some sort of side effects may occur. And side effects is what we don't like. Side effects being the network was busy and it threw an exception, or
Yeah.
something that you can't avoid. The database went down. You can't stop that in code, but we can cope with that side effect. And so I've put some silly data in there. So first off, we're going to get our person, and there we go. It's only me, as it happens. Literally, is just stick my name in, and you'll get me, and then get the order history, which needs the ID of the person. So in my imaginary scenario, we know my name, but we need to know my ID. Hey, it's one, and we're going to get the items that I've ordered, which is some Ida cloth. Now, for explanation, I am a big fan of embroidery, and this is one of my hobbies that I do when I'm not programming. I like to embroider. So these are my embroidery supplies for whatever picture I'm making at the moment. That's what I want to get. But what folks often don't think about when you write this sort of a thing is there's all sorts of possibility for lots of errors outside of your control. And the way that you might do this in like an OOP is you're gonna like we're gonna there we go. Stick all of this in a try catch.
Yeah.
And that's all well and good. You can do that. And yeah, I'd probably log this, but this is a simple example. I'm not going to get too bogged down in real world logic. But what do I return here? I mean, there's a recurring problem. What do I return here? Well, you could return null, but then what you're doing is you're throwing a possible null out to the world, and you're not warning it that it might be a null. That's not very good.
Okay.
You could return an enumerable.empty. There we go. That's a little bit more suggesting something better. I love it when the computer. Oh, look at that. I like that. Very nice. Okay. So we could return an empty array. Yeah, true. We could do that. But that's actually not telling us anything in some ways. So if you've written this code and it's been called from a controller and it's just returning empty, well, is that returning empty because it didn't find it, or is that returning empty because there was a problem? What you would respond
Okay.
to the user with is different depending on which of those scenarios actually occurred. So what we really want is something that's going to tell us whether this operation succeeded or didn't, and it'll have the data if it succeeded and maybe a report of something if it didn't. Okay, so I'm just going to try and keep this as simple as I can. But you could create a big metadata object with nullable fields and Boolean flags and stuff like this, but that's kind of messy. It means you've got fields that aren't needed under certain circumstances, and the code outside has just got to know that you check first this Boolean flag, and then you can look at this field. But now, there is a concept in functional programming called it's called a discriminated union. Let's call this what should we call this? Let's call this result. It'll do. Result of T. Just T, thank you. Thank you. Oh, because I didn't put class on there. That's why. There. So this represents an operation that might have succeeded or might have failed. And a discriminated union is kind of like Schrödinger's type. I don't know if you've heard of Schrödinger's cat. No, that's fine. It was a thought experiment that was invented by a quantum physicist called Erwin Schrödinger, and the idea was that apparently if you would put this cat and a radioactive isotope in a box together, seal up the box, and the isotope had a 50-50 chance of decaying or not decaying, and until you open the box to look at which state happened, which result happened, according to quantum physics somehow, the cat is both alive and dead at the same time, but also neither. And that's
Okay.
kind of how a discriminated union works. It's a type which is one of these two, and I'm not telling you which one until you check. Now, real function, like sort of pure functional languages, things like Haskell and Erlang have got this built in. We don't in C#, so we've got to make do. There are libraries that implement it, but in my case, I'm just going with a public abstract class which has nothing in it, which represents the fact that this is the envelope type. This is the envelope. This is the box. And I'm going to tell it that the contents is one of these two types. So I'm going to make a public class, which I'm going to call success. In this instance, there's lots of different ways of doing this. And result, which inherits off result of t. Yeah, I think I need to put the t there as well. So this represents that our operation succeeded. There weren't any errors getting the data from the database. So I'm going to say that there's a t, and that is I'm going to call it value. There we go. And incidentally, a functional idea that's been handed over recently is now we can do read-only record structs too, which are great for all sorts of reasons, but we do only have limited time. Otherwise, I could talk all day on this, but this is another functional thing that was thrown in for us. And we also need another state, public read-only record struct. We'll call it failure. And yeah, that should. Now, why is that moaning? Oh, not an interface. Oh, I'll tell you what. It doesn't really matter. Let's make it in.
So
type.
I guess,
There we go.
yeah, because you can tell, but everything is within one function here. So
yeah.
The,
These are classes kind of at the moment.
Yeah.
So these represent my states, and let's make that an exception, and we'll call that. No, we can't call it exception. That's a reserved. Let's call it I don't know, error. And that has to be in. Let's make that in it. Lovely. Okay. So these represent two possible states that could be returned, and because they use an abstract t, which could be anything, think of this as being like an envelope. A result t is an envelope, and the envelope either contains a success, and if it's a success, then that envelope contains whatever it was you wanted, which is here. Yeah. Otherwise, if it failed, then it contains the exception that occurred. So that means that what I can do is go to I can now change the return type of this to a result of person. Yeah, that's fine. Don't worry. And we'll call that a new. And we'll say that value is equal to new person. No. Complaining about because success of person. There we go. Yeah, there we go. Now this represents an exceptional case. Now I would also put a try catch around this or something, but this represents a failure. So I'm going to say something like make this a new failure of person, and then we'll say that error is equal to. Now I did make an exception, so. But I'll just make a new exception. I'll say couldn't find. That'll do. What's it complaining about? Invalid error. Oh, I see. There. We happy now? We happy now? No. Yeah. Cut to string. What's it complaining about? Get rid of that. Cannot convert type failure of person to string. Why is it? Oh, of course. There we go. That's it. Right there. Lovely. So what I've done is I've said that in this instance, if you find me, then I'm going to call that a success, and it returns success. If anything else happens, then we're going to return a failure. Now, what you could also do is take this a step further to represent real-world scenarios by putting a try-catch around this. And then if everything in the try succeeds, then we do this, and that's all fine. And if the catch happens, then you do another one of these, a new failure. But this time, whatever the catch error is, you capture inside here and then return that. But the point is that when you call this function here, get by name, it won't fail. There's no possibility that this will throw an error because you've try-caught it and you've wrapped the whole idea of this succeeded or this failed into this result type being an envelope, which you can then examine when you see it on the other side to show whether it succeeded or failed. But the side effect, all the possible side effects are wrapped into this type, and we'd do something similar here. You'd say something like result of enumerable of order, and yeah, I'll just comment this out for now. But you get the idea. You do the exact same thing. You know, like one would be a success. We'd do a try catch and all that sort of thing. You know, I'm just gonna return. Well, just yeah. Oops. Not implemented exception for now, which I would never do in the real world. But that gives you an idea of what it looks like. You know, it wraps around the idea of like the outside world contains side effects you can't avoid, and by calling this a result of whatever, I'm telling the outside world that calls this function. So if we go back all the way to where we started, wherever that is, I think it's over here. Yeah, this is not going to work at the moment. That's fine. We'll sort this. We'll show you. So by making the return type result, or we could call it maybe or option, or we could call it either, there's lots of different ways of doing this sort of same concept. But by wrapping something around the type I want, I'm telling this function here that I don't know whether this is succeeding or not, and you have to deal with it. I'm giving you all the information you need to handle it, but you're going to have to deal with it. I'm forcing you to deal with it. So one method of dealing with all of this at each stage here would be something like go to the person here. There we go. So this is a result of person. We don't know whether that's succeeded or not. And then you could do something like, I don't know, we need the person ID. And then that will be equal to person switch. And then if it was a success of person, and we call that P or S or whatever, then we really get P dot D. It should be, oh yeah, P dot value. Yeah, P dot value, and then inside the value we've got ID. There it is. So if it was, and then otherwise, well, to be honest, otherwise I don't care. I'm just going to say it's -1. So then this means that this value is either -1 or greater than 1 if it's actually succeeded. And then you could do something like if person ID is less than 0, then return. Okay, show one of those. Otherwise, we can carry on, and so on. And we do the same thing here now. And we'd have to do the exact same thing. You'd have to do one of these, use a switch expression to unwrap the package. Like if you think of result as being like the Amazon envelope that's got something inside it. And by calling a switch expression, we're unwrapping it and then working out what we've actually got inside our envelope, whether it's a success or a failure. So that's all well and good. But there is a way of taking this a step further. And a step further is to kind of have a little function made which automatically does all this for you. So hopefully I can do this nice and quickly. So I'm going to make an extension method. Public static. Public static class. It doesn't really matter what I call this. And we're going to do a public static T2. That we're going to get a result of T2. Stop that. And for various reasons, this is called bind. Don't ask, I don't know, but it's called bind. And this is just what you'll see it called around in the world when we're dealing with this sort of scenario. And it's going to attach. It's going to attach to a result of T1. I'll call that this. And then we need a func. Now, func delegate's a function. So shorthand way of writing a function. I'm telling you I need a function. A function that turns T1 into T2. And we'll call that F.
Yeah. So the idea is that all the classes, everything will be in one function, and then you can call different functions with it.
Yeah, I mean, this is like a generic method that you can call from
Yeah.
absolutely anywhere in your code base. It attaches to a result, so you have to be inside a result envelope to be able to use this. So you pop your thing inside a result envelope, if you like. A discriminated union is the technical term,
Yeah.
and then that will like give you access to this. But then inside this, we can do this unwrapping process that I showed earlier. So what I can say is that return. So whatever this is, and switch to say what really is this. We're gonna have a look at whatever this is. This is a result. So a result tells us nothing. It tells us it's a success or a failure. We don't know which one it is at the moment. So if I say that it was a success of T, whatever T, T1. T1's the first generic. That's that incoming type, whatever that is.
Okay.
And then we are going to say that I call that S. And then in that case, I'm going to say this function turns a T1 into a T2, whatever that is. So I am going to say that we want to, let's make that var result. Updated value. This will probably make this a bit easier to look at. And I will call F. And because I know that's a success, I know I've got the value. There we go. And if it's a otherwise, well, no, otherwise, I'm going to say it's a failure of T1, which has got an error inside it. In which case, yeah, I can't use that. That's the point. We can't. So we're just going to return that. It's all right. Right. So this has made a new. This path represents it was a success. In which case, we want to return a new success. So I'm going to do a new success of. It's now T2. And I make the value equal to that. Lovely. Right. And then this is a new failure. But this time, it's a failure of T2, not of T1. And I'm going to say that the error is equal to f dot error. So I'm just passing it along. Right. There. That represent. Oh, I already called that. Okay. Can I call it func? Yeah, you can call it func. That's all right. Yeah, that's fine. Okay. So this is a super simple version of this. I could make this a lot more complicated, but I'm making this really simple. What this is saying is, have a look inside this envelope, this result envelope. If it was a success, then open it, take out the value, take this function that turns the old one into the new one, and then jam that inside it, and it'll turn into a new one, and then put that in a new envelope and send it on its way. And that's what that does. This one says, if it was a failure, open it, take out the error, put it into the new envelope as an error without doing anything. The point is that this function isn't executed if it was a failure. And that means that we can do madness like, and yeah. So instead of doing all of this, we can do away with this lot. Do something like var person. Oh no, we really want a name because new. It's going to be a success at first. It's a success of string. Misspelled the word success. That's always a bad sign. You could make all sorts of extension methods to simplify this process. But again, I'm just trying to keep this short and sweet. So that means that I've basically placed my name inside an envelope. It's now a success because, of course, it works because it's just literally a string I've been given. I could probably examine this to see whether it's valid and then make the decision based on that to make a success or failure. But it means that var result is equal to n dot. Now I've got bind. Bind asks me to provide a function. If I make a little arrow function here, I can see that that is a string. That string there represents literally this one. It's just been passed through. And the SQL Server database get my name here requires me to pass that in. Okay. So this is now equal to a result of a result. Well, that's not very good. So that's fine. There's an easy fix for that. Why that's a result of a result is that this is a result and this thing returns a result. So whatever came out of this, it has taken it and put it into a result in a result. So that's dead easy. We can fix that. Just need to write another one of these. There you go. Just an overload for when the return type is a result, and that means that you don't need to instantiate this. I think we can just.
Okay, so that class does no that result returns T1, that one result T2. Okay.
So think of it this way. The result is an envelope. My thing says, okay, whatever you pass to me, take it out of the envelope, do a thing, get another envelope, and put it inside. And so what this one had done, what this function was doing was saying, this one was also putting it in an envelope. So we were both putting it in envelopes. So now, by having two of these, I've got it checking to see, are you already in an envelope? If you are, then don't bother to get another one. You've already got one. I'll just send you on. And that means that the result, this type, is now simply a result of person, which means I can also go a step further and say dot bind, and then say x, and then pass in the other SQL as the get order history, which also is x.id. There we go. So that is it. That's the result here is a result of IEnumerable of order, which I'll have to change this to, just to say it's a result, which means I don't know if it worked or not. There we go. Turn result. And it works. Right, so let's just talk through what this means. Imagine that this also has a try-catch inside it and a null check and stuff like that, because you could do all of that stuff. It's not terribly difficult to do. I made my version ridiculously simple. But let's imagine that as well as in here, as well as putting this whole thing in a try-catch, which would look something like try-catch and then return failure if it caught, and do a null check, which would return failure if it was a null, that would mean that if this function executes and either it returns null, it throws an exception, or anything like that, then this will receive, instead of a success, it'll receive a failure. Which means that when it comes to this function here, this function's got a check inside it that says, if it's a failure, don't execute this function.
Okay.
So that longer version I wrote before, where I had all that if it worked, then return early and blah, blah, that's all now built in. This bind takes this function, it doesn't execute it, it just takes it and then says, okay, you've given me the function. Before I execute it, I'm just going to check whether I should. And it's going to do the check by saying, this is the old value. Is it okay? Did it fail? Is everything all right? If it's fine, and if nothing results in an exception from running this one, then I'm going to return a success envelope out to you, and it's going to say success. If it fails, if this one fails, then this one will say, okay, the previous one was a fail. I won't execute the function, but I will take the error message out and pass it along the chain, so that this result here, result of IEnumerable, either contains a success with an enumerable inside it, which is what you really wanted, or it contains an error which is got a captured exception inside it, which you can examine. So if you wanted to return this to the user, then you either say, you then do a switch expression that says, if it's a success, then success, here's your data, or failure, here's an error code for you. The point is that this code can't fail. This code can't have an unhandled exception. It's impossible now, because every single function that you pass into this chain has got all of the stuff that you need inside it to make sure that the code won't, that this function, whatever this is, won't fail and throw an exception when you try to run it. So one of the huge advantages of functional programming is it's incredibly error resistant. It's very hard to make functional style code fail in production, or at least fail in such a way that it brings the system down. That you can't get away from failures. As soon as you talk to anything in the outside world, you will get failures. You will get network problems. You'll get users who do foolish things. You'll get databases that become unavailable for one reason or another. That will always happen. But it won't cause your code to fail with an unhandled exception. That won't happen. Not ever. Not if you write your code functional style. And you'll not only get that, but you can get whatever data you want to be returned to you when a failure happens, so that you can both log it and report it to the user so that they can know what the problem was. So
Yeah.
it's code that never fails. That's its
Plus,
huge advantage.
you can write it in a way that you use less code because remember before you showing that you have more code in one classes and now you compress it into one class.
Yeah, that's another huge advantage. It tends to be much more concise because, like I said, that whole rigmarole that is pretty typical in OOP. That you need to do things like null checks, you need to try catches, and blah blah. You'd have to do that for each one of these lines, but in functional, it's all built in. So this is, I mean, I can't give you exact figures on how much shorter your code base will be, but it's
Yeah.
significant. It's at least a third or more of your code base just gone because you don't need to write it. You don't need to write all that defensive code that you normally need to write in OOP to ensure that your code doesn't fall over. It's just
Okay.
not necessary. It
Yeah.
makes your code easier to read.
So what's some of the best practice of writing good functional tests for good functional programming?
Well, I mean, the main thing is to understand how it all works. I mean, it does require a change in the way that you think
Yeah.
and the way that you write your code. And that's the hurdle. That's the hurdle to jump over. But once you're over that, it actually becomes simple. The paradigm itself enforces the sorts of rules that make good code. It tends to force you down the lines of writing small, compact functions that are doing only a single thing and tend to have no real failures in them. So the paradigm almost enforces good code structure itself.
Yeah.
The main thing is just to learn how it works, and it involves just learning stuff like this. Now, what I have made for you here is something called a monad. Now, that's a name that you may have heard around out and about, but this is actually all a monad is. It's just kind of like a relay race of functions that where you pass a series of functions, and like a relay race, it passes the baton from hand to
Yeah.
hand, except it's data rather than a baton. But it's the same
Okay.
basic idea.
No worries. Are we using anything to do with AI in functional programming, like
You
creating
can.
an app or something?
I mean, those are completely different spheres. You
Yeah.
can write AI in functional, or not, but that is no bearing whatsoever. It's
Okay.
not in and of itself AI or not. It's just a style of writing code. AI is about application of what your code does.
Yeah.
We're lower level than that. Functional is how do you
Oh,
write that code in the first place?
yeah.
That's we're down in the weeds in the maximum level of detail when we write this stuff.
Yeah.
So
Okay. So if someone want to get started in functional programming, how can they learn more about it?
sure. Well, I could be very churlish and mention that I did, in fact, myself write a book on the subject. It's called Functional Programming with C Sharp. It's by myself. That is Simon Painter. But I should also point out that there is a most excellent book also on the subject by Enrico Buonanno, which is called Functional Programming in C Sharp. Now, my book is published by O'Reilly. Enrico Buonanno's is published by Manning. And I think we're both pretty good books. But either of those would be a very good place to start. I have numerous talks that I've given on the subject, which are available on YouTube if that's of any interest to anyone. I also do workshops if anyone's company wants to bring some of these benefits in. I'm sure that I'm sure they can reach out to me and we can have a discussion. But
Yeah.
there's
Sure.
plenty of material out there, plenty.
No worries. Uh, so I'll add it to the show notes. Yeah. So thanks for joining this podcast, Simon. So it's quite we learn about some functional programming. So I hope everyone knows some bit of functional programming is quite useful, and is how it can be everything can be built in functional. And yeah, so thanks for joining. So let's just before we end the podcast, we just want to know a bit more about yourself. So, uh, what I see you're like an MVP. So, are you doing any community activities, like doing any talk or events? Like you mentioned, the
Certainly.
workshop.
Sure, that's the thing I've started doing recently. But yes, I do an awful lot of talks. I travel around a lot doing talks for user groups. That is for like little local .NET meetup. In fact, I'm doing one next week in Manchester. I've been doing that for about 10 years, I think now. And I also attend international conferences and I give talks. I was at NDC Oslo recently, and I was at Tekorama in Belgium, in Antwerp, and I give talks at them as well. And as of now, I do workshops as well. So yeah, I do a lot of public speaking. I started at community conferences in the UK, events like DDD East Anglia was my very first one, and stuff like that. I've kind of worked my way up to attending some slightly bigger conferences, but I still attend all of the community conferences and community events around the UK, at least any that will have me and that
Yeah.
are within travel distance of me, because
All
I
right.
love speaking at these things. I
Yeah.
really enjoy getting out and traveling and meeting people and talking about all of this. So
Yeah.
yeah,
And
I do a lot
I
of
know
outreach.
there's a difference between like speaking than actual just blogging, because I like speaking because it improves like soft skills as well and your interaction with people. So it's a plus one for anyone that want to get into public speaking. And before we close the podcast, are you going to any other events? And you said you got user groups talk next week. Where is
Yeah.
it?
So next week I shall be appearing at .NET North in Manchester. I tend to be something of a regular at .NET Knots, Pete Gallagher's meetup, so hopefully
Yeah,
I'll be there before long. I don't know if you know Pete,
yeah,
but
no,
he's an awesome guy. I in September I am going to be going to NDC Copenhagen, where I'll be once again talking on all manner of things. I don't have much else planned after that, but I
what's
have
your
applied for.
what's your session in Manchester on NDC? Is it the programming or is it just different?
Certainly is. Yeah. Yep. 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 And when I go to Manchester, I shall be talking about how I once made a computer game based on an old 1970s computer game entirely in functional style C sharp. It was
No,
called
okay.
Oregon Trail. I literally found some source code from 1975 on the internet somewhere and converted it myself into modern functional style C sharp. Oh, I will also be appearing at B sides in Leeds. That's actually I'm going to be talking security there. That's one of my other topics I talk about. That's a security talk.
I thought
Um,
B-sides data, like a data event.
which one? Sorry.
B-side, don't you mention, because saw it somewhere online that it's like a date or something. I'm not sure if it's developer.
Well, the one I'm at least the talk I'm giving is on security.
Okay,
It's my talk is about what you can learn about security from really terrible Hollywood films.
okay. So
It's just a bit of fun. I have applied for other events, and I'm hoping I'll be popping up at stuff early next year. But I've kind of burned through a lot of my leave and my availability for this year,
Yeah,
so
sometimes you
my
just have
fingers are
to not apply it once, spread it out, so
yeah,
so
yeah,
you don't
yeah.
use it all
I
at
should.
once.
Yeah,
Yeah.
my fingers are crossed at the moment for NDC London, but we'll see. That's not up to me to whether I get that or not.
Okay, no worries. Yeah, finger crossed. No worries. Thanks for joining this episode, Simon. So hope everyone learn more about functional programming and learn about like what Simon does in developer conference. So if you want to see Simon, you can go to the .NET North thing in Manchester. Use the group
Please do.
next Thursday or something, or
It's next Monday, I think.
next Monday. Yeah. So the details will be on like a meetup is .NET North. So just Google it on the meetup.com and you just need to register it. Okay. Thank you. Bye.